Hello everyone, welcome to the CJC CCTV certification program. I'm Jeff Miao, the trainer from Hikvision. The topic of this course is audio and video fundamentals. Let's start with learning objectives. By the end of this course, you will understand the application using audio and video and grasp basic concepts of audio and video. In order to achieve the training objectives, we set the training content in 3 parts. First, audio and video overview to get some basic knowledge, and then go on with audio concepts and video concepts. Let's begin with audio and video overview. Both audio and video could be transmitted in CCTV system. We could see the workflow from the picture. The built-in microphone will collect the sound of the environment, and then the audio will be transmitted to the backend. Also, the camera will collect the light to generate video. The video will also be transmitted to backend. Alright, as we are clear about the workflow of video and audio in CCTV system, then let's check the application of them. We can see from the picture, there are 3 parts in CCTV system: the front end, transmission, and back end. First, let's see the audio. The environment sound could be collected from the audio input device, the camera. Then the audio could be transmitted to back end. If there is anything abnormal, the operator from back end could realize audio output by talking to the microphone. Then let's see the video. Cameras could generate video. Then the video could be transmitted to backend through the network. And then the video could be displayed on video wall and stored in storage device like NVR or DVR. In the first part, we get the basic knowledge of video and audio, mainly the workflow and application. Now let's go with the second part to see the details of audio concepts. First, let's see the audio signal workflow. Microphone is to collect the sound and generate analog signal from the camera. Inside the camera, there are 3 modules to deal with input audio signal. ADC converts the analog signal into digital signal. PCM deals with original audio digital signal. And DSP codes and encapsulates the digital signal. Then the camera outputs audio streams for transmission and recording. Inside the camera, audio signal will be processed by several methods, including audio mixing, audio noise reduction, echo reduction, volume adjustment, and audio output. Audio input microphone and pickup are 2 types of device for audio signal collection. Microphone is passive device connected to mic in of camera. Pickup is active device connected to line in of camera. In the second part, we get the basic knowledge of audio concepts, mainly the audio signal workflow, audio signal processing, and audio input mode. Now, let's go on with last part to see the details of video concepts. First, let's see the worldwide video standard, NTSC and PAL. Their standards originate from the television industry. NTSC uses refresh rate of 60 frames per second, or 30 frames per second. PAL uses refresh rate of 50 frames per second, or 25 frames per second. The total amount of information per second is the same in both standards. When analog video is digitized, the maximum amount of pixels that can be created is based on number of TV lines available to be digitized. Then let's see how to define image definition. Resolution is to tell the definition or size of digital image. The unit of resolution is pixel. All images, video or static, are measured in pixels. In analog world, each pixel is composed of 3 colored dots: red, green, and blue. There are 2 dimensions of pixel, width and height. Resolving power is to tell the definition of analog image. The unit of resolving power is TVL, which is short for TV line. There are also 2 dimensions of TVL, width and height. There are 2 types of resolution, as you can see from the table. Standard definition resolution is less than 1 megapixel. For safe and safe are commonly used standard definition resolution for capturing picture. High definition resolution is more than 1 megapixel. 720p or 1080p are commonly used high definition resolution for video. Now let's check the size difference of high definition resolution from this picture. We can see from 720p, this is 1080p, and this is 2 megapixel, and 4K. The size from bigger to bigger. As we are clear about the video standard, now let's see the basic video concepts. First, we need to know what is video. Actually, video is made up of a series of continuous images. Each image in the video is called a frame. The basic parameters to describe video is frame rate. Frame rate is quantity of frames per second, measured by FPS or frames per second. Normally, the video in CCTV system will be compressed for transmission. So the video after compression is called stream. There are normally 3 types of streams: video stream, audio stream, or video and audio composite stream. The basic parameter to describe stream is bitrate. Bitrate is quantity of bits per second, measured by BPS, or bit per second. There are 2 types of bitrate: constant bitrate and variable bitrate. Frame rate could determine the video quality. More frames per second means a more smooth video. 25 frames per second is real-time frame rate to show you a smooth video. If the frame rate is lower than that, it is called low frame rate. Video of low frame rate is not so smooth as that of real-time frame rate. The iframe are compressed entirely without dependence on previous frame. The P frame depends on the previous frames. It comprises the difference between the previous frame and the actual frame, then compress only the difference. HD video makes it possible to see more details, but at the same time, it brings extra cost on transmission bandwidth and storage. The video compression standard is a key to help you to reduce the cost and enjoy HD imaging, as we can see from this picture. Now we are clear about the basic concept of video. Let us see how to set suitable bitrates.
Because of the resolution limits, higher bitrates do not necessarily guarantee higher picture quality. Also, higher bitrates require more bandwidth. This means it will take more time for computers and mobile phones to load a video. We recommend specifying bitrate settings for different resolutions and encoding times. Setting a suitable bitrate will ensure good image quality and a fluid remote preview. For example, a bitrate of 4 megabit per second is the optimal value for 2 megapixel 25 fps H.265 configuration.
Then let us see how to set suitable FPS.
Frame rate per second, or FPS, is the number of individual video frames that your camera captures per second. Higher frame rates will make a video play more smoothly. We recommend setting a frame rate higher than 15 FPS to guarantee fluid video feeds. Meanwhile, a lower FPS for less important channels will liberate your bandwidth significantly, which is especially helpful when there are 9 or more channels.
That's all for this part. Now let's make a summary. In the first part, we introduced the audio and video wheel, focused on transmission and application. In the second part, we introduced the audio concepts. Audio workflow is from microphone to camera, finally to backend device. There are 2 types of audio input device, pickup and microphone. Several audio compression standards could be used for audio. In the last part, we introduced the video concepts. Video is composed of image. Each image is also called a frame. We could use resolution or resolving power to describe the definition of image. For resolution, there are standard definition and high definition. Resolution of standard definition is less than 1 megapixel, such as full safe or safe. Resolution of high definition is more than 1 megapixel, such as 720p or 1080p. The video after compression is called stream. There are 3 types of stream: video stream, audio stream, and video and audio composite stream. Bitrate is to tell the quality of stream. Bitrate per second is the unit. There are 2 types of bit rate: constant bitrate and variable bitrate. Frame is image of video. Frame rate is quality of frames per second, measured by FPS. There are 2 types of frame, iframe and pframe. That's all for this course. Thank you for your time.